Hi, I am Vaibhav Shamoli. My roll number is 230350100039. I am a BSc Honors student in the domain of Artificial Intelligence and Data Science at IIT Guwahati, and I am presenting my internship presentation for trimester 7, in which I was interning at Ltid, Long Term Industrial Development, which is a company that is based in Japan that usually help businesses by automating their tasks with the use of different technologies with the help of AI, and they have multiple projects that they are working on and researching on. I was a part of the project known as the photography project, and I have been working with them since my late November 2025. My work was to build a pipeline in which we were working with the raw images of students from different schools in Japan and turning those images to different to like to produce those out to like Adobe InDesign or for attendance purposes, or we can work around like for detection of the students in the corridors and everything. But I was a part of the initial phase, which was the yearbook part. And let me explain why we have been come to this situation. Like usually there are a raw photo of each student that can be around 5 to 6 photos of each student, and while working on them and to find the best output of them, it usually takes to 4 to 5 minutes to analyze each photo. And in like there are 45 students in a class, so you can assume it takes around 1 hour, and then to place those images in Adobe. If you have worked with Adobe, it usually takes a lot of time to place images and arrange them and align them. So usually we were working with different classes and different schools, so there were around 20,000 images that needs to be placed in the correct order. But the reasoning is that it can take up to a lot more time than we were expecting it usually. So we were asked to automate this task. So let me proceed with the whole procedure. So as you can see right here, we have the code for this. So let me go with the images, like allow a moment. So as you can see right here, so here are the images of the student. Like these are quite refined right now, testing with the small input data that we have. So these, you can see that this image, or we can have other images. So what I wish to inform you is that there were multiple images like this, and you cannot be sure which image they are smiling, and on which image they have their eyes open, which image is not blurred. So we need to check everything and then proceed with the placement of these images. So what we were doing is that initially I learned that to find the best image, to find the roll numbers of these students, it was a task for us too. So we have to find the best possible image. So the libraries and the dataset was provided by the Japanese school, and we were working on Google Colab, as you can see, and that was with the model T4 GPU. We're using the GPU T4 because like if we have to buy the cloud GPU, which was not initially, we were not expecting this. Actually, I'm to say is that the GPU that we were provided by the collab was much more simpler to use, and it was a free tier version exactly. So we were happy to work around with it till we were getting to the main part. We have the code and everything ready. So we I worked with the face detection and the face recognition with the inside face buffalo large model, which is a bundle of two different frameworks, and that is of retina face for detecting faces and everything, which has a precision of 91.4% with white faces and hard benchmark. And for recognition, we were using the arch face, which has a hit of 99.83% in the LFW verification benchmark. So this what needs to be done to recognize faces and to extract metadata from those images. And then as you can see, there was some images. As you can see, they are holding the roll numbers as their card. So these roll numbers needs to be needs to be extracted from this. So for this we were using the OCR model. Earlier there were some Japanese letter as well, but they were removed by the school. So we were earlier using parallel OCR, which is trained in the kanji and furigani, that are two Japanese languages. So to recognize them, it was a quite difficult task for the other OCR. So parallel was working fine, but it has a major issue, major drawback, that parallel OCR is a heavy model. It takes a lot of time to extract the images. It gives precise answers, but it just takes a lot of time. So we went to easy OCR, and easy OCR we were able to create a specific area, a pixel where it has to check for the numbers, and it was able to work around that. As you can see, it was able to give the number 4 or number 5. And other than that, we worked with the GPT-4 model for the OCR thing also. I'll go with that too. Allow me a moment. So here are the names and the paths that we have defined initially for the schools and everything. You can see that at first, for the card detection, for the roll number detection, we have the easy OCR that was working very well with it, and to detect the quality of the images. So for the images, I was thinking regarding this, that we were using to score the images with the GPT-4 vision model, which was able to give us the best images, but it is also expensive. So we were trying to work around keeping that, and other than that, we are keeping one more case to check for the sharpness of the images initially. If we are able to recognize on the basis of that, I mean to say, on the sharpness, contrast, and everything, if the photo has a best output and is smiling according to the metadata, then we do not have to proceed with the GPT-4 model. If we are unable to do that, then we can fall back to the GPT model to extract the best possible photo regarding this. Okay, and then we have, okay, this is the code for this one. Yeah, I will be pushing it in the Git, so you can check from there. Just a moment. So for the face embeddings, we were able to extract the vectors of the face vector data, which was a 512 dimensional embedding vector, which we were able to extract using the Indesign face model. And one more thing to emphasize, that there are multiple photos with the same image, right? You can see that I might be having 3 to 4 photos of the same image. How do we recognize on that part? So you were using the cosine similarity, which is the basic, and we were able to distinguish the photos. We were able to find a sweet spot for that, that is on 65 to 55, in which the photos were able to be distinguished in different folders to be considered as similar photos, and we were happy with the results regarding that. That was a sweet spot for us, and 55 worked very well according to that. And then when you can go to the card detection. Card detection has a place, as I told you, boundary, so it was able to speed things up for us. Other than that, I have the scoring model works on 5 different signals. So confidence gets the 10% of it, head posture get the 30%, and it penalizes if the student is looking down more than 18 degrees sideways, or more than 25 degrees, or tilt their head more than 20 degrees. Eyes open get 30 degree. I use the eye aspect ratio from the Sokopuwa or Sheikh. With thresholds, I calibrated from our actual portrait data. Sharpness is 15, measured by Laplacian variable, and brightness is 15%. On the top of that, there's a gesture penalty. A lot of Japanese students do the peace sign in their photos, and the system detects by looking for the skin color blobs outside the face area and penalizes those shots. So a photo with a peace sign gets ranked below a clean portrait. Interesting is that when I first started, the problem was actually different. Initially, we had one image per student, and the task was to enhance it and fix the contrast, sharpness, color balance. I spent a lot of time on image processing for that. Then the workflow changed, and the photographers started providing multiple shots, and I was able to work around with it. It was much more easier to work with it. And then stage 3, as let me go through the stage 3 just a moment. Wait for on the module part, just a moment. I'll come back on this just a moment. As you can see, this is the stage 3 part. Stage 3, it takes the best shot and exports them with the naming convention. It like gives you the names by extracting the names and giving the best shot. As you can see here, it says that the ID single one and second is multiple. Best shot will be named as the best shot image, and these were all saved into a manifest.json. I can show you which we have. Okay, here we have the manifest.json. As you can see, this also have the offsets. I'll talk about the offsets, how offset we have been working with. And just a moment. So then we can go ahead to computing the face alignments. Now we have completed the part where the face was processed. We have figured out the best shot images by the scoring model and everything, and now we are proceeding to align those images in InDesign. So what do I mean by align, right? So align, as let me open the InDesign for project. So here you can see that this was, allow it some time, it takes a little bit time to open up. Okay, so let me help you with this one before that. I think that will not be opening. And as you can see here, these are the portrait of the student that have been placed here. And so the problem is that every student has a different face, right, for the face alignment part, and different hair and different forehead. It's like you just center every image and the frames end up at a slightly different position, and the yearbook page looks very uneven. When this requirement first came up, I hard coded the offsets. I looked at a bunch of images and I evolved the right value by trial and error method, and had number, and it worked, possibly worked for many of the cases, but it broke at some students with different proportions, right? They have a long face or different. So then I have to like think about it, why we are facing such kind of an issue, and then I wrote the offset calculator, which were using the media pipe face mesh to detect the three landmarks, that is the chin, the left eye and the right eye. These are the three images. These three things needs to be extracted, and it computes a scale, and the factor was the equation where it would set the vertical and the horizontal offset for each and every image. As you can see right here, that whenever you click on these, let me shift to this one. Okay, these are the empty template, and the result is that the face ends up in the exact space between these red lines. As you can see, here are these red lines in between, so the face would end up in the exact position with the proportions. And you can see that here was the exact one initially I had shown you here, right? Let it open up. So before we proceed with that, I'll just show you. Okay, so here we are. Here we are. So this was for one of the schools who I run, and as you can see that the offset was like most of them get placed like this. Image is not the best image right now. I'm not using the best photo image data. These are all the random images we had with them. So you can see there are multiple photos. That is not working right with this. Okay, so one more thing is that then template, one more problem that came up with me with that was that the template size. As you can see, the template size for this, the small template, and for this one is all different. For this one it is all different. So the problem was that I was only hard coding these frames, but then the size of the frames started to fluctuate, and it was for every template there was a different size. So what we was thinking after that was to build something which was built by one of my teammates, and that was one of my colleagues. That was the export frame dimension, and that reads the it was initially my idea. I have presented that to the team, that we can extract the frame first, then we can, according to the frames that we have, we can calculate the offset, and according to that we can give a manifest.json. As you can see right here, which right now you can see these offsets, scale how big or less it should be. We have the chin size, eye distance. So these were the factors that were, so we, with these we were able to create the best possible output. And as you can let me know, so after that the automatic identification rate was up to 97 to 98%, which means only 2 to 3 students after 100,000 needs a manual review. So the case that still trips up the like blurred cards, black cards or something similar, but we were able to reduce those with the OCR model. We were able to optimize those with, thanks to my team. And for the face alignment, the reference data set, like 86.9% of the entries got valid compute offsets, 13.1% got fallback offsets, and 0 had a complete failure. The detected chin position clustered tightly between 0.478 to 0.520, which is telling me that the media pipe is considered throughout drive a uniform cropping policy. Processor speed was about 2 to 3 seconds for per image, and it was reduced to around 1 second only afterwards. And the alignment for those were the GPU. If you have a GPU based computer, you will be able to go much faster with it. It depends on your system's compute after end of the day. And so this was how it was working. Initially I had a fallback with the JSX script. As you can see, this after that the Python code, we went to the this we have like right now is it at version 13. Right now we started at 1, we were able to achieve the output at 8, version 8, but then we have to move to a different thinking to the requirements of the project. So it was shifted to the layer based layer away. So there are different layers for in the InDesign part as well. So the layers were we are like able to go render check each layer for each component, and then we were able to place like extract frames from there and then place images there. So that is how it was. It reads, let me just showcase once the InDesign, it will be better to understand. Just a moment. I hope this is working. No, it's not working. Okay, let it open for a while let me put the other context for these, like so working with this was like honestly like we are like facing such a height of like time, like a person has to spend a whole day to manually place these images and everything. But now with the help of us, we were able to automate this, and the images were able to be placed here automatically, and it reduced the time to really less period. Right now I have the version 10 here with me that is currently working. So here it go. So it was able to place the images like this, as you can see right away. Just give the system is right now not connected, it is not charged, that's why it is facing some issue. Just give me a moment. Okay, so here we go. So here we are, like the images are being placed, and that was the success from our side. We have, if I would be able to give more input on this, if we had a, so I'll share the code in the Git regarding this, and you can go through that. If you have any questions regarding it, you can send it to my Insta or mail. Sure, and we can thank you for that. And this was all from my end.